So warm welcome from me as well from sunny Ilmenau. I have the pleasure of guiding you today through a 2 hour session, roughly 2 hour session on Introduction to Research Data Management. So this will be a newbie introduction to the topic of RDM. It will be, as Roman already said, fairly interactive. I've got like a few surveys and stuff. And I will have a break in between because it's a long session that I will announce to you. Um, but you may also ask questions in between. For that, you can either type your question into the chat or just wait until part one is over. Then I'll have time for some questions. And also after part two, I'll have time for some questions. And if it's really urgent, you can also unmute yourself and just ask your question then. So whatever works for you, basically. So yeah, since we've got all the housekeeping out of the way already, let's just have a look at the agenda for this session today. What we're going to do in part one of this session before the break will be terms and definitions. So we're going to talk a little bit about what's what. We're going to talk about then secondly, the data lifecycle that research data go through and data management planning. Then we're going to talk about data documentation. And as I've already mentioned, after that, there will be time for questions if you have any. So as I said, either hold on to your questions until there or write them in the chat if you want. We're going to have a 15-minute break after that. And then we're going to, in part two, be talking about repositories, open science and FAIR principles, legal aspects, and licensing of data. I'll be giving you a little summary of what we've already gone through and give you some support options for research data management and some more information and where you can find it. And then we'll have a bit more time for some more questions if you have any. And that will be that for today. Okay, so let's get started right away. I'm going to start with a survey. And I would like you guys, so you can already participate now. So I'd like you guys to go to menti.com and use the vote code you see on the screen, and then enter up to 3 words or phrases that you think of when you hear the term research data. Okay, excellent. So I think we can all see what we're working with today is basically I think all of us understand that research data are the basis of your work as a scientist, and a lot of different topics surround them. And you've already mentioned a number of things that we're going to be talking about today, like data planning, open science, fairness, and so on and so forth. So I'm really happy that you guys are already bringing up so many of the topics that will be part of this presentation and of this workshop today. Now, let me switch back over to my presentation and let's get into things a little bit more. So, we're talking about terms and definitions. So when we talk about research data, we got to know what even are research data. So for our intents and purposes, there is no one size fits all definition of what research data are, but rather it depends very much on the discipline, what kind of data you'll be working with. But in general, one can say that they are documents in digital form, with the exception of scientific publications, so we don't count those as research data, that are collected or generated within the scope of scientific activities. And you can see that this definition is very broad, and that is because, as you can see on this next slide, that research data are extremely diverse according to which discipline that you are working in. So they can be pretty much anything from audio, video files, or images to mathematical, chemical, physical formulas. They could be experimental simulation results, measurements, observations. They could be documents, for example, in the humanities. They could be survey and interview data, specifically in the social sciences. In the more technological oriented sciences, it could be also software code, algorithms, scripts, and so on. And they can also be simple text data or also social media data, Twitter, Instagram, and so on and so forth. Um, so already we can see that the definition of research data is a very broad one. And the challenges that you will be faced with will depend on what kind of data you're working with. Now, when we talk about research data management, we've now defined what research data are, but what even is research data management? So, research data management is generally thought of as the structured and planned use of measures and procedures for the selection, transformation, storage, archiving, and publication of research data in the research project and beyond. And the entire goal of research data management is making research data long-term sustainable and available. Um, and you might ask yourself, okay, that kind of sounds like a lot of work. Why should I even be doing this? So I've put on this slide a number of reasons why it's a good idea to do research data management. And the first one would be that research data management guarantees a long-term and person-independent access to data. It's the first one. It also provides reuse and multiple use of data, and it enables validation, replication, and transparency of research results. I'm sure all of you have probably heard the term reproduction crisis as it pertains to the sciences, which is mainly the whole idea that it is very difficult to validate and reproduce scientific results without properly managed and accessible data. So we try to avoid that from happening by doing research data management. Then also through proper RDM, we can safeguard third-party rights, whether it's scientific subjects or other third parties that are involved. And we also ensure that we do ethical research. So this would be where the CARE principles sort of come in. The CARE principles, don't know whether you guys know them, are sort of principles that make sure that all stakeholders that are involved in your research get ethically treated and that your research is based in ethical principles. I'm not going to be talking about the CARE principles too much today, but if you're interested in that, you can maybe ask a question in the chat and we can provide you with a link to the CARE principles or something like that. Also, research data management will ensure that you're in compliance with the principles of a good scientific practice, and it will also enable better reusability, more citations and recognition for your research, but also for your group and for your scientific community. Now, that we've put the terms and definitions behind us a little bit, I want to talk about the research data lifecycle. Why do I want to talk about this? It's quite simple because for us, the research data management experts, we don't look at research data management as something that you do once and then you're done. It is something that will sort of be with you for the entirety of your project and the entirety of the life cycle that your research data go through in within that project. So, there's different visualizations of what the research data lifecycle could look like. I generally go with this like six-stage one, which goes from planning, your project and your data generation or collection, and then to the actual data collection, analysis and processing, access to the data and publication of the data, storage and archiving, and then hopefully the reuse of the data that will then maybe lead to like new research, new projects, and then the whole cycle begins again with the planning stage. Now, throughout that whole research data lifecycle that your data will go through, different methods and RDM measures that you will take apply. So in the planning stage, for example, before your project even starts or at the very start of your project. You will have to plan all your project stages and all your RDM measures that you're going to be taking, specifically all the ethical, legal, and financial things that you need to plan out. And you might be writing a data management plan at this point. During the active project stage, so while you're doing your data collection or generation, your analysis, your processing, your collaboration, all that stuff, you will have to think about your methods of data collection. What software tools are you going to be using? How are you going to be ensuring that your data of good quality? How are you going to organize them? How are you going to make sure that you have a good backup strategy? And how are you going to deal with documenting your data? And which metadata are you also going to collect? So those are all considerations during the active project stage. And then you will have the stages towards the end of the project or even after the project, where you're going to be thinking about storage, especially of the cold data that you start working with, long-term archiving, repositories that you're going to be maybe publishing your data in, going to be thinking about open science and fair principles, and about legal aspects and licensing. And all the ones that are like in fat, in bold print, we're going to be talking about today. So almost all of them. We don't really have time to touch in detail on everything, but I'm going to try to talk about the most important ones. Okay. Um, so after we've sort of done all that and like thought about all that, I want to like basically start at the beginning, what we just said, and talk a little bit about the planning stage of your research data and your project. And this will start with a data management plan. Now, what is even part of a data management plan? Like what are you supposed to put in there? You probably have heard of it. Most of you will likely have not written one before. So in a data management plan, you will give at least the following information. Administrative information like your project name, your funder, maybe your funding number, that sort of thing. Then you will have a part that deals with data description. So it will describe what data am I going to generate or collect, what types and formats are they in, what methods will I be using for that, and will they be available for reuse? Will it be possible to reuse them? Then another section of the data management plan will address documentation and data quality. So this will be mainly about what metadata will you be collecting and how will you be documenting them and according to what standards. Then another section will deal with storage and backup. Where will you store your data? How you make sure that they're properly backed up and such. And then you'll be having a section on legal and ethical requirements. So is there anything that you have to think about in the way of legal aspects of your research data generation or collection and publication? Um, then after that, there'll be a section on publication and long-term storage. So after you've published your data, where will they go? Um, and the second to last one will be who will be responsible for all of this. And then the last one, last section of your data management plan will generally deal with your budget. So you will have to think about, do I need a budget? How much money do I need? What do I need it for? Um, and there are some tools to assist you with this. For example, the OpenAIRE cost calculator is available, and will sort of guide you through the process of thinking about what kind of budget you might need. And you're going to want to think about that early on because generally you will have to put your budget and what you need into your project proposal. So thinking about this after the proposal is through is a bit too late. Um, yeah. So this is what goes into a data management plan. Now, a lot of you might not have yet written a data management plan ever, and might be thinking, okay, yeah, but how do I do this? So there are resources to help you write or create your first data management plan and also all the subsequent ones. For example, up here in the upper left-hand corner, we've given you a template, which is a generic Word file that you could use to like start off your first data management plan. But if you're like, okay, I don't even know what to write in there at all, there are example DMP collections that you can access online. There's one on Zenodo, Fedra, which is Austrian platform that collects data management plans, or also the collection by the Digital Curation Center, or linked here for your convenience. Oh, and by the way, I don't think we've said that yet. The slides will be made available for you, so you don't have to worry about like looking this all up right now. Um, and then if you are like, okay, but I'd like to see more discipline specific examples, there are also a number of those. We've got two examples here from the social sciences and the humanities. And if you need even still more help, there are tools, software tools, that will be guiding you through the entire writing process. And there are many different ones. We've got RDMO, which is a German tool, DMP Online, Data Stewardship Wizard, Argos, and so on and so forth. All of them have like slightly different focuses and slightly different features. And if you're not sure which one's for you, we've linked for you our DMP tool guide that we've set up, which compares all these different DMP tools, and sort of give you an idea which of the tools is good for who and for what purpose. And then you can select one. Personally, if you are a researcher in Germany, I would always sort of think, okay, RDMO is kind of a good one to start, because it is a German tool and has a lot of templates for German funders like the DFG and so on. But generally, they're all good choices. It's not really like one's very much better than the other. It just kind of depends on what you want and what you need. Okay, so this is sort of like a quick start into writing data management plans. Um, However, data management plan writing is not always mandatory. It really depends very much on your institution and who is funding your project. Just so that you have an idea of what that means, I've put up a little table of different funders and the data management plan requirements because they differ wildly. If we start with like the European Commission and their framework program Horizon Europe that's running right now, they do require you to write a data management plan. And at first you have to write like a short one with your proposal and then hand in an extended one in month 6 plus a final version at the end of your project. They do provide you with a template for that, as to the contents. And as is already been made clear, they do require regular updates to your data management plan. So this is a relatively like strict requirement on the researchers that do their work in EU-funded projects. Then we have the biggest German funder, which is the DFG, which they do not require you to write a DMP, which by the way doesn't mean that you shouldn't. You still can. They just don't require it of you. But they do require information on the handling of research data in the proposal. So when you're writing the proposal, you will have a section where you have to give these specifics anyway. And the contents should be oriented towards their guidelines on the handling of research data, but they do not require an update on that currently. Then we have the BMBF, Bundesministerium für Bildung und Forschung. With them, it depends very much on the project and the funding program that you are in. If you have to write a DMP in your program, then you generally need to submit it with the proposal. And what contents they want and whether an update required also depends on the project and funding program. So unfortunately, I cannot be very much more specific than that for the BMBF. And then I have another one, the Volkswagen Stiftung, which also do require a DMP to be written and handed in with the proposal, and they want it to be oriented towards the contents of the Science Europe practical guide, but do not require an update. So you do see requirements vary quite a bit according to your funder, and your own institution, university, institute, and so on can also have requirements as to whether you need to write a data management plan or whether it's, your own choice whether you do that. Yeah, so that's a little short excursion into the world of data management plans and data management planning. And now we're going to go on to the active project phase, and documentation and metadata. So firstly, I want to talk a little bit about why should we even be doing data documentation? Because it is, a bit of an effort, like writing down all of the stuff about your data. So I've put up this slide for you as an example of how information degrades over time, so-called information entropy. Whereas at the beginning, when you're working with your data and you're in the project, you know a lot of details about your data, you know everything about them. But then very quickly, specific details about problems with like individual items or specific dates are lost relatively quickly. And this then continues over time and is made even worse if you have like a technological change or accident or something, or if a person retires or you lose your data developer. So this already shows that data use is difficult or impossible without metadata and documentation, since information does get lost over time for yourself as well as for your own group and third parties. Um, and that data documentation is often the only long-term form of communication between the data author and the data user. Now, what is data documentation? Data documentation is the precise recording of the development of research data in the research process with the aim of making data comprehensible and reusable, and it should contain information on workflows, technical environments, and processing steps. Um, so that is the basic definition of data documentation. Now, next. I want to show you the definition of what metadata are, because the section is documentation and metadata. So metadata are data about data that come in a standardized and structured format. So they're basically a standardized and structured description of your research data. And they should be ideally as discipline specific as possible. So you can see on the right-hand side, there is a picture of the Taj Mahal, and then there's some metadata on the side about that picture. So that's kind of the idea. Now, metadata should ideally be provided in both machine and human readable form. Why? In human readable form, I think we can all understand so that humans can understand what kind of data they're looking at and what they're dealing with. Machine readable form is important since in this day and age, most of our research data will be put online and will be hopefully searchable by search engines and other platforms. And this is only possible if you provide the metadata in machine readable form as well. Now, most repositories will take care of that for you. They will be exposing machine readable metadata, if you've given them any, to all these search engines via standardized protocols. So you don't have to worry about that. But you should definitely think about what metadata you want to provide in human readable form. Now, we've talked a little bit about what are metadata and what is data documentation. Now I want to talk a little bit about what you should be documenting. So generally, it's all like the W questions with like one H question thrown in there. But basically, you want to go with who, when, where, why, what, how. Who generated or created the data? When and where were they generated or created? Why were they generated and created? How were they generated or created? So that means which technology did you use, which work environments, software versions, and data cleansing methods. And then also what is the content of the data? So any variables and labels that you might have, analysis parameters like units of measurements or time, etc., should also be documented. So that's one thing about what to document. Um, Next thing I want to talk about is metadata standards. Now, a lot of disciplines do not have a metadata standard that they use in their metadata collection yet, or they have a standard that is unique to their group or their institute. However, there are already a lot of metadata standards out there that are described and available for use. Some are more general ones, like the DataCite metadata schema, Dublin Core, mods, etc., PP, or mobs. But there are also a lot of discipline-specific ones. Now they it looks like this when I show you all of those. So for the social sciences, the humanities, biological sciences, earth sciences, chemistry, geography, medicine, etc., there are many different kinds of metadata schemas and standards. And if this is a bit overwhelming and you don't know whether there's one for you, there are ways to look that up, either in the metadata standards catalog, the RDA metadata directory, or at fairsharing.org. So if you log onto those sites and you can't find a discipline-specific standard for you, very likely there isn't one yet, or it's being developed as we speak. In that case, you will always be able to like fall back to like the more general metadata standards that are basically discipline agnostic that can be used for any discipline. Now you might think, okay, well, I found several. How do I choose one? So as I already said, you want to go with what's the most discipline specific for you, and what fits with the type of data that you're using. Your organization or your project might have guidelines on what to use, so you should check that as well. And your publisher might also have specific requirements. For example, your repository or whatever else you're publishing. Um, Specific requirements on what you should provide, what kind of metadata. So you should check that as well. Um, and then it also depends a little bit on the resources that you have available to generate metadata. So if you already have a workflow that generates them like in an automated way, it'll be a lot easier than if you have to do it like manually by hand. So all of these things will sort of go into the consideration of which metadata standard you might want to choose. As I already said, if you can't find one that's specific to your discipline or your research area, you might always be going with a more generic one or more general one that is discipline agnostic, such as Dublin Core. I've sort of put Dublin Core and all of its elements on the screen for you. So Dublin Core has like 15 core elements that are all like optional, but can also be repeated. Um, so you have elements that pertain to the life cycle, like the date, the ID. You have technical metadata like format, type, or language, content metadata, what subject are the data about, what area do they cover, is it description, title, and you have metadata about the author of the data file, like creator, publisher, contributor, and rights, as well as some elements that pertain to linked data, such as relations to other data sets, sources of the data, etc. Um, so this is something that you can always use if you don't have the option of using a discipline-specific metadata standard. And there will be more information on dublincore.org. I put the link on the slide as well. Okay. Now that was already a lot, I'm sure a lot of input. And next we're going to have another Menti survey that I'm going to put on very quickly. All right, I think we're getting a pretty good idea of what most of you guys are doing. I'm not seeing anything that's super exotic right now or that I've never heard before, so that's already a good thing. We're very happy about that. Um, we're going to just return to the presentation. And let me also just put up. There we go. Okay, now We've already seen that most of you do pretty much what I've got on the slide. A lot of you said lab book. Now, this is obviously an analog one. I think a bunch of you will probably be still be using this type of like paper notebook for the lab. Some of you might already be using like eLab or whatever else you've got, like electronic laboratory notebooks. I'm going to talk about those in part two as well. Then I saw a bunch of you said I use a README file, which I think is a super common option. What I haven't seen in the survey is a data dictionary. Some people, especially in the social sciences, use this, which is like a very specific way of like writing down, okay, what's my file? What data type is it? What method did I use? Like very methodic way of documenting that. And if you are involved in like doing a lot of like surveys and polls and such, you might be also documenting your metadata in a code book, where you basically have all your variables of your surveys and the variable name listed in this code book and what they mean and what kind of values they can take and so on. Now these are probably the most common ones. And then we've got the electronic no, lab book. I did see markup language once, and also JSON files. So this is kind of where we are here. And then some people also use Jupyter notebooks for documenting their metadata. Uh, or for documenting the data in general. Yeah, I also have a few practical tips for data documentation for you. If you do work with a README file, or want to work with a README file, we do have a template for you on our repository Refodat, that we would like to make available or have made available for you. So if you haven't really got anything yet that works for you, consider looking at that. There is also like a generic make a README page that you can use and make your own. And there's also README templates on GitHub that you can use. And there's a template by the Open Science Framework as well. So if you post or publish research data on the Open Science Framework, they also have a specific template that they suggest you use. And this last one, as I said, is the one that we provide here in Thüringen on Refodat, which you can see on the left. So you can basically download that openly on our repository. We also do have a coffee lecture specifically on how to create those README files, what to put in there, etc. So if you're unsure about that, you can also click on the link once we provide the slides for you and like look at, okay, what do I do with this template now? Now, another way of sort of giving your files more context or more metadata is file tagging, especially if you work with Windows. So in Windows Explorer, you can add keywords to your files. So if you look at this example right now, this is a presentation for a coffee lecture. And if you go to your Windows Explorer, click on the file, on properties, details, and add tags, you can add all kinds of different tags that you want for your specific file. How that works in detail, I've put a file tagging guide, a video on that slide as well, so that you can sort of see how exactly you're going to do it. But it's actually relatively simple, and the video is also very short. Last thing on data documentation forms is this table where I've sort of put an overview of what kind of data documentation forms there are and what kind of features they have. So I've put the forms of documentation on the left-hand side, and on top there are all the features like, is it human readable? Is it machine readable? Are the metadata structured that you will be collecting? Is it searchable? Is it time-stamped? Is it an open format or closed one? And is it standardized in any way? And you can then look at this and decide, okay, what would work for me and what is important to me. Like, do I need a timestamp? If not, can I go with just a README, for example, and so on and so forth. So I hope that this is also useful to you. Um, we are going to go on though and talk a little bit more about electronic laboratory notebooks right now. So there are many different kinds of electronic laboratory notebooks. Don't know what you guys are working with. Here in Thuringia, we're establishing a Thuringia-wide instance of ELAB FTW right now. But there are many like more proprietary non-open source ones like Lab Folder, ELAB Journal, and so on and so forth. RSpace has recently opened their source code, so there's many different choices. Um, as I said, in Thuringia, we will be very soon be able to provide um, access to ELAB FTW. If you have questions about that, please put them in the chat, or join us tomorrow for our talk on ELAB FTW. Um, and then last but not least, I want to talk a little bit about the benefits of good data documentation. Because there are a lot of them. Firstly, it will be easier to collaborate with one another in your group, but also with colleagues from outside. You will have more efficient workflows if you have good data documentation. You'll be avoiding repetition, and the data will be more easily reusable and will comply with the FAIR principles a lot more. And it will enhance reproducibility of your data. So whoever looks at your data will be able to reproduce what you've done. And we will continue now with part two of our Introduction to Research Data Management session. Welcome again. Um, and I want to talk to you right now a little bit more about our end of the project stage. So you might remember the research data lifecycle from the beginning of this presentation. We've already sort of covered the planning, data collection, analysis, and processing stages a little bit. And now we're going to talk about access and publication, storage and archiving, and then sort of reuse. So this is like towards the end, after the end of the research project, basically. And topics that we're going to cover include repositories, open science and fair principles, legal aspects, and then at the very end, we're going to talk a little bit about licensing. All right, off we go. So data publication. Anyone who hasn't published data yet, but even people who have already published them, always like encounter a number of challenges and questions. So one of them is, or the first one basically is, where should I publish? And then how do I find a suitable data repository? Should I publish open access, restricted access, or closed access? How do I make my data sustainable? And which license do I choose for my data? Now these are all very important questions. And before we go to address them, I would like to do a survey with you once again. It's the last one, I promise. Um, Let me just put it on the screen for you. A little bit more time. But I think we can already see that most of you are using a data repository of some kind to publish your research data. Um, and then the next most popular option seems to be doing a journal article and then giving a data supplement to that article. Apparently, one of you's already done a data journal article as well, which is a lot of effort, so commend you for that. And a few people have also picked institutional websites. So basically putting the data on the website of your institution or your group or whatever. I already want to say, like, that's better than not putting anything out at all. But if that's the only thing you do, maybe it's not. If that's the only thing you do, I would strongly like to encourage you, as well as the people who don't publish anything at all or haven't yet. I would like to strongly encourage you to think about publishing your data in a data repository. That will be the most um, common option, or at least as a data supplement. Um, okay, I think that's everybody right now. So let's go back to our presentation and let's talk a little bit about data publications. Now, we've already seen in the survey, and I've already mentioned a number of them, that there are different data publication options, and there's mainly three of them. So the one that will generally apply to most of you will be a data repository that you pick where you upload your data, you fill in some metadata fields, and hopefully give some data documentation in some form. And then you click publish, and it's online. Um, I've already seen that one of you's also written a article in a data journal. So we're going to talk about what these are in a little bit as well, so right after this slide, in fact. And then some of you have already also done a data supplement in a journal. So basically, you publish an article and in Science or whatever it may be, and they ask you, okay, can you give me your data? And then sometimes those will be given as a supplement, open access. Most of the time, it's kind of behind a paywall, though. So yeah, uh, not the ideal option in my opinion. In my opinion, data repository should be your first option that you go to, or also an additional option. Even if your journal asks you to hand in a data supplement, you can still publish in a data repository yourself, since you have that right as a German scientist. You have right of first publication of your data. Now, let's talk a little bit about what data journals are before we come to the more generally applicable option of data repositories. So data journals are basically peer-reviewed journals where you write in-depth um, article about your data set and describe your methods and all that stuff. Some do have or contribute to your impact factor. Um, or to your H factor, they do give your data that they do store in either their own repository or a repository they're associated with a persistent identifier. So it is a proper data publication. And there's a whole host of data journals that have sprung up over the last couple of years. There's a list of data journals that I've provided for you on the slide, hosted by our colleagues at Uni Jena, where you can actually have a look of which kind of data journals are available right now. Now, as I've said, this one is quite a lot of effort, and generally, most researchers will rather be going with the option of a data repository. So what is a data repository? It's basically a database in which digital objects can be documented, archived, and published. And they enhance the visibility and sustainability for your data via the use of a persistent identifier that you're given for your data set and the metadata that they ask you to fill in. And they generally provide transparent information on usage rights for your data as well as for the repository as well. Now, there are different kinds of data repositories. There are generic or so-called catch-all repositories, which just basically take data from anyone for any purpose. Then there are also discipline-specific repositories, which, as the name already says, will only take data from a specific discipline, and will also oftentimes provide specific features for those kinds of data or even data curation. Depends on the repository though. And then there are also institutional repositories, which, for example, Refodat is an institutional repository for the whole state of Thuringia, but there might be other institutions like bigger universities that have their very own data repositories like Heidelberg, Munich, and so on. The ones with more money than we have. Um, Now, you might be saying, okay, how do I find a suitable repository for myself there? And this is made a lot easier by the use of re3data.org, which is a registry of research data repositories. It has over 3,000 repositories listed, We've just got Refodat listed there as well, so you'll find that too. It provides information about quality criteria for the repository that you're looking at, and also different search filters. Like on the right-hand side, you can see you can filter by subject, content type, which PID systems are used, and so on and so forth. There's many different search filters that you can use to find a repository that's right for you. Now, if you found a number of them and they all kind of look good, you might ask yourself, okay, then how do I choose a suitable one? Which are the criteria that I should go for? Now, basically, there's some questions that you just need to ask yourself. Do I want to publish open or closed access? Does my repository that I'm trying to choose provide these access options? Um, which usage or licensing conditions are given. Like the license that I want to use, does the repository provide that or give me a way of like at least telling them I'd like to use this license? Um, then, as we've already talked about, you might want to pick discipline specific versus institutional versus generic. That might be a consideration. Um, and you might want to think about, does it give me the usage of the PID, the persistent identifier that I'd like? Most commonly, it will be the digital object identifier, a DOI anyway. That is what most repositories use, but it isn't the only system that's in use. What it definitely should have is one of these systems. So it should be able to give you a persistent identifier, since that is what will point to your data publication in the future and where people will find it. Um, then another question might be, is there curation of my data provided? Some generic repositories do it, like Lifodat, some don't. A lot of discipline, or let's say a good number of discipline-specific repositories provide some kind of curation, either just for the metadata or also a scientific curation. So that might be a question that you might want to ask yourself, as well as long-term availability, which can be either checked in the repository's policy, or if you can see that it has a certain certificate, like on the right-hand side, the Core Trust seal or the DINI certification, that might also be a good indicator for longevity. And then lastly, you might want to review the repository's policy on handing in data. How many can you hand in? Do they have an upload limit? And so on and so forth. So that might also be a deciding factor. Um, Now, I cannot possibly show you all discipline-specific repositories that there are, because there are a lot. But I have provided for you an overview of selected catch-all repositories. So even here, this is not the entire list. This is just some of them that I've picked. Most of you that have published in a repository might already be familiar with Zenodo. It's the EU's catch-all repository that's hosted at CERN, which has like a couple really nice features, relatively easy to use. So this is like oftentimes the go-to option, but there are other ones like the EU.project repository B2Share, Open Science Framework, open source repository. Then I've put the Springer Nature Publishing Group repository Figshare just as an example of where your data would go if you do like this whole supplement thing. Um, then there is the IEEE Big Data Initiative repository, which has been, as of lately, the only repository where you can deposit big data. But now there's also Refodat, which is the Thuringian Research Data Repository. So if you're a Thuringian researcher based here in the Free State, you can also use Refodat. We also do not have an upload limit for file size. So this is an overview of a few generic catch-all repositories that you might want to use in case you can't find a suitable discipline-specific one for your needs. Okay, so much for repositories. And going forward, I want to talk a little bit about the FAIR principles. I've mentioned it already a couple of times, the term FAIR. Let's like dive into what that actually means. Now, the FAIR Principles is an acronym for the words findable, accessible, interoperable, and reusable. And those are basically the things that we would like your research data to be at the end of your project. And it kind of works like this, that if your data are findable, accessible, and interoperable, they then generally become reusable. And these principles were first published in 2016. I'm going to go into a bit more detail about what each of these terms means, but if you want to find out even more, I've put the link to Go Fair and the FAIR principles on the slide. So if you want to learn more about that than you can in this session, you can do that afterwards when we make the slides available to you. Now, what do all these acronyms mean? So basically, findable means that your data are findable online by being indexed in search engines and by having a persistent identifier. Um, Findable, though, is not the only thing that we want them to be. They also need to be accessible via that place that you have found them in. And that is generally done via the identifier and a standard communication protocol, such as HTTPS. And also accessible means that at least the metadata for the entry need to be openly available. So if your data are published in closed access, there might be some use cases where that's necessary. At least your metadata should always be openly available for everyone to see. Oh, okay, that's the data that are here in closed access. That's what they're all about. Then interoperable means that you use open and standardized formats as much as possible, which is then easier to harmonize, and that human and machine readable metadata are provided. And then it comes to reusable, which means you provide documentation, a clear license, or stating that the data are license free, and some provenance information for the data that you've provided. So provenance information means where do they come from, what can I do with them, etc. This can also be put in the documentation itself. And if you do all that, that means your data will become more or less fair. So it's like not they're either fair, they're not fair. It's a bit of a scale. The first three, findable, accessible, and interoperable, if you use a up-to-date modern data repository, will generally be taken care of for you. Um, in like a very standardized structured way that you don't have to worry about it. If you publish on Zenodo, on Pangea, on whatever like modern repository there is, they will do all this for you. They'll give you a persistent identifier. They're indexed in search engines. They will ask you for metadata to put into the graphic user interface and so on and so forth. Where you really come into play is making them reusable by choosing correct license, providing information about your data, providing documentation, etc. So this is basically what we understand by fair data principles. Now, a word on fair versus open data, because these can overlap, but they're not the same. So not all open data are fair, and not all fair data are automatically open. What does that mean? Um, Basically, if you openly publish your data on somewhere, for example, an institutional website, with no further documentation, no metadata, no nothing, the data are open, but they're not fair, they're not reusable. Um, and even if you have fair data, so they're published on a repository, they have PID, they have metadata, they have documentation and everything, but you can't make them open. That doesn't, for example, for data protection reasons or other reasons, that does not mean they cease to be fair. So they can still be fair if they're not open for good reason. So these two are not necessarily the same thing. They can coincide there. So a lot of fair data are also open data. Um, And the guideline here is you want to make your data as open as possible, but as close as necessary to comply with like legal aspects or ethical aspects of the whole process. Now you might wonder, okay, so how again do I make my data fair? Like, what can I do? And I've put this on a slide for you as well. So basically, as I said, where you come in is mostly with the letter R, with the reusable. And what you want to do is provide detailed data documentation. We've already talked about that in a README file, electronic lab book, or whatever that you link to your data publication. You should use discipline-specific metadata standards, or at least a generic one. Give information about your methods of creating your data and the relationship between the data that you're publishing. And you should also give information about the provenance and the licensing of your data, which will then increase the chance that your data are compliant with the FAIR principles. Now, if you've already published data or you want to publish data and you want to like see, okay, how fair are my data really? How well do they already comply with these principles? There are tools that you can use for that. And on the left-hand side, there are some self-assessment tools. This one that I've put here is the ARDC data self-assessment tool. We have the TKFDM network has adapted this tool and sort of like modified and optimized it a little bit. It's still in a better version, but I've put it on the slide for you as well, since my colleague Kevin Lang will be talking about the fair assessment tool tomorrow, I believe. So if you're interested in that, tune in for that as well. There are also like in the middle, the Fuji tool, like fully automated self-assessment tools or assessment tools rather, not self-assessment tools. So what you do there is just you provide a DOI or a URL to the tool, and it then sort of hands you a score for that associated data set, and it also tells you where your data set could be improved. Um, we have, as the TKFDM, created a fair assessment tool guide where you can find information about all these different tools, how to use them, and who they're for. And you can find this tool guide on Zenodo if you would like. But you can also always ask your local help desk as well for help with this stuff, with assessing the fairness of your data. Now, if there are no urgent questions, we're going to go on to one of our last topics today, which is the legal aspects of data, research data management. And they really come in at basically any and all stages of the research data lifecycle. So in the planning stage, you will have to think about policies that apply to your project, ethical aspects, collaboration agreements. Then in the usage stage, like data collection analysis, you will have to think about data protection laws that might apply, usage rights, copyright, patent laws, and so on. When you publish your data, you will have to think about publication requirements from your institution, your funder, about embargo rules that might apply, and so on and so forth. And then in the reuse stage, data protection, copyright, and licensing come into play. So you see that legal aspects really play quite a big role. Now, the reuse of data is generally permitted for scientific purposes and is regulated by the General Data Protection Regulation in Europe, as well as the German Federal Data Protection Act and the laws at federal state levels they apply. But there are a few things that you will have to comply with if you do want to use personal data for your scientific endeavors. We do have a workshop on this. It is in German though, so I apologize. It's not in English. But if you want to know a little bit more about copyright in data, you can refer to this workshop that we've got up, as well as if you want to know more about licensing and usage rights. But I am going to talk a little bit more about licenses as well, namely right now. What even is a license? A license is a contractually agreed upon right of use. It allows the rights holder to allow their contractual partner to use data in various ways. For example, maybe to copy the data, store them, make them digitally accessible, change them, etc. It depends on which license you choose. Generally, in research data management, what applies is that licenses should be as open as possible, but as restrictive as is necessary for your purpose. So you might ask yourself, okay, that's great, but how do I know which license I should choose? We have a general recommendation for the publication of research data, which is either going with the Open Data Commons scheme or with the Creative Commons licenses. And if you don't want to use either of those, but you do still want to use a license scheme, then there is a tool called Choose a License online, which will guide you through the decision process. Um, Generally, as I said, it is good to choose a licensing model according to the openness. So ideally, you want to be as open as possible. And I've already put a few licensing models on this table. So Creative Commons, Open Data Commons, and Community Data License Agreement. According to more restrictive licenses on the left, towards increasingly more open licenses on the right. Um, and you kind of see like with this green little divider in the middle, the right-hand side is more of what we would recommend. So anything on this side is what we would recommend for the licensing of research data. On the left, not so much. I will talk a little bit more about why that is. Now, I want to talk a little bit about Creative Commons licenses. So this is one specific licensing scheme that's out there that we do recommend. They have a standardized license text, which reduces the effort and creates legal certainty. You just pick the one that is suitable for you. And there's no transfer of exclusive exploitation rights with Creative Commons licenses. So you're still free to work on your own data, even if you apply one of these licenses. They are internationally distributed and recognized and compatible with a large number of jurisdictions around the world. So it helps avoid issues in international context, which, let's be real, the academic context is a very international context. And they are suitable for the licensing of text as well as data publications. But this is a bit of a caveat. They're not suitable for licensing software, code, or anything of that nature. There is also a selection tool if you need help with selecting a CC license, and I've put the link on the slide for you. And a little bit of an overview of Creative Commons licenses. So we have the CC0 license, which if you apply this, it basically makes your work, your data public domain, waives all IPR and copyright conditions. The work basically people can do whatever they want with your work. They can copy it, change it, and so on and so forth. And you might be like, okay, but why is that good? Why do I want that? Basically, the more open your license is, the higher the probability that people will actually be able to reuse it and use them for their own scientific purposes. Now you might want to say, okay, but I want people to at least know that they're my data. Then you can go with an attribution license, so-called CC BY. However, do be aware, even if you apply CC0, it is still good scientific practice to quote who the data that you're reusing are from. So that's just basic common courtesy, even if you don't have to per the license agreement. Another choice might be if you want to be sure that your data are shared under the same conditions as you made them available, is picking the CCSA, the so-called share alike license agreement. What we would not recommend is picking CCND, which means no derivative works. It's self-explanatory. If you use this license, people will not be allowed to change your work in any way, create derivatives of it. And also, you should be careful with the CCNC, which means you're licensing your work as only for non-commercial use. This also applies for scientific projects that are not fully publicly funded. So you want to be careful with this one. It is quite restrictive in the academic context. So yeah, again, the one that is in the red box, those ones we do recommend the ones down here, not so much. Okay. I have a practical exercise for you guys right now. How do you deal with data? For example, let's say you have images from different sources with different licenses that you want to use in your research. Which of the images with the licenses can you combine down here? So that's the first task. So which of the ones are you actually able to combine? One, two, or three? And which of the licenses would then apply? Um, I do have the solution on the next slide, but I would just like you guys to think about this for a moment and maybe write your solutions into the chat or unmute yourself and like just maybe say it just like that. That's also okay. Um, so just take a moment, like which of these will actually work as a combination, if you want to use the different images. Let's say image one, image two, which won't work, and why? I want to give you the solution to this. So how do you deal with data from different sources with different licenses? So the first one will be combination of CC BY, so attribution, and CC BY share alike. This one would work. Number two, CC BY share alike and CC BY NC share alike would not work. Does anyone know why this would not work? Can you understand why that would be a problem? So this wouldn't work because you'd have to combine two images where the one is licensed share alike and the other one introduces a new licensing condition and then with the non-commercial. So that's problematic and you can't combine those. And then the third one, CC BY and CC BY ND, would also not work since you'd have to combine data from sources where the one says it's a non-derivative work, but you do want to work with them, and the other one says, oh, you just have to give attribution. Um, so this is a little bit of an exercise to think about Creative Commons licenses in a bit of a different way. Now I want to give you, as like sort of a last thing on Creative Commons licenses, a few recommendations if you want to work with these. CC0 is generally suitable when it is doubtful whether copyright protection for your data even exists, or for metadata or quantitative research data. Why? Because most research data, like just purely measurement data, tabular data, stuff like that, are not protected by copyright in Germany. So if you're uncertain, CC0 is a good way to go. Also, if you're uncertain, of course, always contact your local help desk about this. Be careful with non-commercial licenses. I've already said why. This can easily lead to your research not being able to be reused by other projects if they're not fully publicly funded. CC BY ND makes integration into other databases and working with the data very difficult, if not impossible. I would not recommend that, as I've already said. CC BY 4.0, on the other hand, is fast becoming the established standard when you're working with Creative Commons licenses and is a recommendation from our side as well. And is also recommended by the EU Commission and the DFG for publishing research data. Now, if there are no urgent questions about licensing, I would like to give you a few take-home messages sort of as a summary. Um, so basically, the first thing I would like you to take home is that research data management begins with the planning of the research project. So already far before your project actually starts, and at best, it starts with the writing of a data management plan. Metadata should be collected already at the time of data collection, since that is when the memory of what your data are and what kind of metadata are needed to describe them is the freshest. And you should always have like sort of this 20-year rule in mind. So the metadata of a data set should be written for a use case in 20 years' time. So what does a person need to know in 20 years' time in order to reuse the data? And you should prepare the data and documentation with a user in mind who is not familiar with your project, not familiar with your methods, and not familiar with your observations. Okay, so those are like four take-home messages for you. Now, in summary, I would also like to give you a little bit of a summary of the data lifecycle again. So before your project begins, you might want to think about pre-registration, planning your project, and data management planning. We do have either coffee lectures or other workshops and talks prepared on all of these topics. The video and slide links to all of these are on this slide. Some of them are in English, some of them are only available in German. So, yeah, apologies if not all of them are available in the English language. We're kind of working on that as well. In the active project stage, you want to think about data organization. We have something on the 5S method for that, documentation metadata, creating codebooks and README files, documenting and planning data processing, data quality, backup, encryption, as well as using ontologies, terminologies, and controlled vocabularies. So you've got resources for all of those things as well on the TK-FDM side. And then after the end of your project, we've already talked about it just now, data publication in Zenodo, in Refodat, information on legal aspects, data publication in general, open science, publishing and licenses. There are resources on all of those topics available as well. So basically, throughout the entire data lifecycle, we've got you covered. If you want to know anything in more depth, just please refer to any of these resources available to you. Now, if that's not enough and you need further support or resources, we've also put some of them on the slides right now. And I want to start out with what a research data management support infrastructure generally looks like in Thuringia. So like your first point of contact will be your local research data management help desk. So this is, for example, at TU Ilmenau, this would be me. At the other universities, it would be my colleagues. So all Thuringian universities, and at the moment, the universities of applied sciences have a help desk that will give you advice on writing applications and proposals before, during, and after the end of a project that will generally provide some kind of RDM training, RDM materials, and will also help you with the referral to data stewards if you need to involve them in your project as well. Then the second layer of support will be your university IT center, who will generally handle stuff like storage and backup, provide cloud services, server hosting and housing, will sometimes provide options for long-term data storage and software. Then your legal office will deal with legal aspects. There might be a data protection officer there generally with declarations of consent and copyright issues. And then your local library or the Thuringian University and State Library, TULP, will give you access to literature and information, access to research data, open access publication advice and financial support for that, as well as the publishing of research data via Refodat will be available through that. If you have any further questions or a need of further support, FDM Thüringen and so TK-FDM and FDM Hawk project and all of the people working in it are available for you. I've put the contact information on the slide. If you just want to browse a little bit, we do have materials on our website as well. So we have a lot of information materials such as handouts and best practices about all sorts of research data management topics. We have a resource on electronic laboratory notebooks. We have the 23 RDM things, 23 free license things. So if you want to know more about that, you can check that out. We do have a research data scary tales game if you're more in the mood for a little bit something more light or want to incorporate it into your own teaching. And we also have event materials, which is basically the slides and audio recordings for all our coffee lectures and all the previous editions of the research data management days in the previous years. And if you don't want to go there, you can also just go to our YouTube channel with over like 70 videos I think we've got up right now, or to our Zenodo community for all our written resources. I also do have a bit of a shameless self-plug still for you right now, which is a bit of an announcement for our online coffee lecture series, which is still running. It's in English this semester, so all of the dates will be in English, all of the lectures, and the upcoming lectures will be on June 25th, so next week on data publishing, and then there will be one in August, August 6th on research data management in funding proposals at 2 p.m. each, goes for about half an hour. It's like a nice little compact format. It's online, it's free, and you can find more information and registration at the link that I've provided on the slide. So if you want to know a little bit more about those topics in English, you're very welcome to join these coffee lectures. And if you do want more discipline-specific research data management information, you might want to go to the National Research Data Infrastructure, Nationale Forschungsdateninfrastruktur, that started in 2020. What is the NFDI? It's basically 27 consortia developing discipline-specific infrastructures and services from all sorts of disciplines. So from the humanities, social sciences, life sciences, natural sciences, engineering sciences. Um, we've provided a link with an overview of all NFDI consortia that are available right now to you on this slide. So if you want to go there and just pick the one that applies to you and your discipline, you are free to do so. They have excellent resources as well that are tailored specifically to your area of research. So I can just recommend going there. We've also put the NFDI general site down in the right-hand corner. If you want to go there directly, you can also do that. But I do recommend the overview. It's quite good. Um, all right, and this is all the resources I want to give to you for today. Um, and also conclude part two of this section. And this is now your chance to ask any questions.